Now that we have discussed the different states of matter, we can discuss changes in state. So let's begin with looking at changes between solids and liquids. When we are discussing water, which is H2O, in its solid form, it's known as ice, and you can see the particles are packed really tightly and are vibrating in place. In its liquid form, it's called water, and you can see that the particles are a little bit spaced out and are moving over each other. And in its gas form, it's considered water vapor and is moving and filling the spaces that it is in. So, thermal energy in particles of the same substance increase from solid to liquid to gas. So that means that the thermal energy in gas, or the water vapor stage of water, is greater than the thermal energy in its liquid state, and even greater than its thermal energy as a solid. The act of melting is a change in state from solid to a liquid. When a substance melts, the particles in the solid vibrate so fast that they actually break free from their fixed positions. And there's a temperature at which we call the melting point. And in most pure substances, melting occurs at a characteristic temperature. And this point changes with air pressure. So if you've ever noticed that there are different cooking temperatures or different cooking directions for high altitude, this is one of those reasons why. Because melting point, or the temperature at which a substance will melt, changes with air pressure. You can see here in this image that as something melts, with the addition of heat energy, the particles break free of their stable location and they begin to slide over each other. So that change from the solid vibration to the liquid state. Freezing occurs when there is a change from a liquid to a solid. So when a substance freezes, the particles in the liquid move so slowly that they begin to take on fixed position. And there's actually a decrease in heat energy. So here you can see that the particles are moving freely over each other, sliding. And here you can see that with the decrease of heat energy, they are now closely packed and they are locked in place, vibrating. Now when we change from a liquid to a gas, we have new vocabulary. Vaporization is the word we use to describe the change from a liquid to a gas. And this takes place when the particles in a liquid gain enough energy to move independently, forming a gas. Evaporation refers to vaporization that takes place only on the surface of a liquid. So for example, when you see a puddle in the morning, over time, with the heat of the sun, the water that is on the surface, only the surface of the liquid, begins to vaporize. As that top layer vaporizes, that now gives a new layer, top layer, and that layer can then vaporize. Boiling refers to when a liquid changes to a gas below the surface as well as at the surface. So for example, when you're boiling water, the vaporized water molecules form bubbles below the surface, which rise and eventually break the surface of the liquid. So when you watch water boiling and you see those bubbles rising, that's because vaporization is occurring both at the surface and below the surface. The boiling point is the temperature at which a liquid boils and is also dependent upon the air pressure. It's important to know that the lower the pressure, the less energy is needed. So when you are at a high altitude, that means there's less air on top of you, less air pressure. The amount of time it takes for something to cook will be lower because things will boil sooner at a lower temperature. The higher the pressure, the more energy needed. So when we are at lower elevations, that requires more energy to get something to boil. Condensation refers to a change in state from a gas to a liquid. In this, particles in a gas lose enough thermal energy to go back to its liquid state. Water vapor is a colorless gas you cannot see. Steam, clouds, and fog are actually not water vapor. They are tiny droplets of liquid water that are suspended in the air. It's important to note that. But we will see condensation in action when you have a really cold drink. You'll notice that there's water that appears on the outside. That's not the glass leaking, but that's actually the water vapor that's in the atmosphere coming in contact with that cold temperature and changing from its gas state to its liquid state. And you see that as condensation on the glass. My personal favorite phase change is actually changing directly from a solid to a gas, and that word is sublimation. So sublimation is a change in state from a solid to a gas. It never goes through the liquid phase in sublimation, which makes it kind of special. In this, the surface particles of a solid gain enough energy that they form a gas. The particles of a solid do not pass through the liquid state as they form a gas. And examples of this are things like dry ice. Dry ice is a solid carbon dioxide block. And when it becomes a gas, it cools water vapor in the nearby air, which is what forms the fog. So that's why it's used, especially at Halloween time, to create that foggy look. So sublimation is something that's a little special because it doesn't follow the normal routine of moving from solid to liquid to gas or gas to liquid to solid. It goes directly from a solid to a gas and skips that in-between stage.